All right, here's our last video, example number 5 from section 6.3. We've been talking about least common multiple and getting common denominators. This example asks us to find equivalent expressions that have a common denominator. So right now you can see that they obviously don't have a common denominator, and we need to have them make them into common denominators. Now, before we can get them to be common denominators, we've got to figure out what the denominators are made of, what their factors are. So the first thing you need to do is you need to factor your denominators. So you can see I've factored the first one into an x plus 6 and an x minus 1. I've factored the second fraction's denominator, we're using a difference of squares, into an x minus 1 and an x plus 1. If I want them to have common denominators, they all have to have the same factors. They have to have the same stuff. If you look at the first fraction, it has an x plus 6 and an x minus 1. What factor is it missing that the second fraction has? Is it missing an x plus 1? So in order to get a common denominator, I need to give him an x plus 1. But remember from before, if I want to keep them balanced, if I multiply the bottom by x plus 1, I have to make sure that I multiply the top by x plus 1. All right, look at the second fraction. If I want him to have a common denominator as the first one, what factors in his denominator is he missing? What does he need that the first one has? Well, right now he has an x minus 1 and an x plus 1, but it looks like he's missing the x plus 6. So let's multiply the top and the bottom by x plus 6. These two rational expressions are the same, equivalent to these two rational expressions, the originals. They just have now common denominators. All right, we're going to get good at that. We're going to do some more common denominator stuff in the next section when we actually add and subtract them together. Before we move on though, I'd like you to try a few problems. I have two try-it problems here. One is asking you to find the least common multiple, and then one is asking you to find the least common denominator. I want you to practice finding the common multiples or common denominators between these two terms and these three fractions. I want you to pause the video, come back to me, and make sure that you can find a least common multiple and a least common denominator. All right, the first one. I broke the 18 down into 2 times 3 times 3, and then I also have a t squared, or t times t. The second one, I broke down into 2 times 3, that's 6, and then I have 5 t's. But remember, they all have to have the same stuff, a common multiple. So, what number is the second one missing that the first one has? Looks like it's missing a 3, right? So now they both have a 2 and 2 3's. But what is this first one missing that the second one has? Well, he has 2 3's, not 2 3's, 2 t's, but he needs 5 of them to be the same as the second one, right? So he needs 3 more. They now have a common multiple. They have 2, 3, 3, and then 5 t's. Really, they have an 18t to the 5th, would be the least common multiple. Hopefully you got the same thing I did. All right, number 2, because they're fractions, are asking us to practice getting a common denominator. But before we get a common denominator, we have to make sure that we break them down into factors. The first one I factored into an x plus 3x plus 3. The second one I factored into a 2 times 2 times 3 times x. That's really a 12x broken down. The last one I broke down into a 2 times 2 times 2, and then x times x times x. That's really an 8x cubed broken down. And now everybody needs the same stuff. The first one has an x plus 3 and an x plus 3. But what else does it need that the other ones have? It looks like it needs 3 2's, a 3, and an x cubed. If I do that to the bottom, I have to make sure that I multiply it to the top as well to keep my fraction balanced. So really I just multiplied by a 24x cubed. The second one had a 2, a 2, a 3, and 1x. But what is it missing that the other guys have? Well, he's missing a 2. He's missing an x cubed. Did I make another mistake? Ugh, I'm not doing very well, am I? It actually only needs 2 x's. If it already has one, doesn't it just need 2 more? Right? So that was my mistake. Sorry about that. So that it has 3 x's altogether. And then it's also missing the x plus 3 and the x plus 3 that the first fraction had. So it needed a 2, it needed an x squared, and it needed 2 of these guys. So can I really just say it has an x plus 3 squared? And if I multiply it to the bottom, I have to multiply it to the top. All right, let's hope I didn't make a mistake on this last one. This one already has 1, 2, 3 2's, but isn't it missing a 3? It's missing the 3. It already has the 3 x's, so that's good, but it's missing the x plus 3 and the x plus 3 that the first fraction had. So it really needs 2 of them. It needs a 3 and an x plus 3 squared. All right, now that everybody has the same stuff, let's look at what the common denominator is. You should have 1, 2, 3 2's. That's 2 times 2 times 2 times 3. You should have an x cubed in every single one, and you should have an x plus 3 and an x plus 3 in every single denominator so that there's a common denominator. Really, you should have a 24, that's 2 times 2 times 2 times 3, an x cubed, and an x plus 3 squared. Now the numerators are going to be different depending on what you had to multiply by, but this would be my common denominator. Whew, it only gets better by practice. And we all make mistakes, so just be careful with that, but make sure that you practice by doing your homework. Ask me questions if you need to. We're going to get a little more challenging as we go through this chapter, so make sure that you're really good. You practice a lot with this section before moving on, okay?